So what we're doing is measuring the activity, and what that does is it gives us a result in time. And first, what we do with radiocarbon results is we look at this y-axis here, and this is radiocarbon determination BP. And what that's suggesting is how much, if there was an absolute value of carbon, of radiocarbon, how old would this have to be absolutely, right? Now, once we have that, we have to accept the fact that due to the Seuss effect, which is dead radiocarbon being released by fossil fuels, and then also the nuclear bomb tests, which actually brought a lot of active radiocarbon into the atmosphere, that we have to make corrections for that. So this blue line that goes across this chart here, what it does is it shows tree ring correction from the 1950s and estimates the amount of radiocarbon present. So then finally, at our calibrated date, what we can say with the most certainty in a 45% probability with a 78% certainty that this particular sample was likely between 987 and 10,047 years old. For archaeological investigations, this date can be very useful in understanding and interpreting the area, the timing of an event. Sometimes they refer to the area and to the people as different things. So you can compare the environment to the people. Are these people who are inhabiting a place over and over, or is this a new inhabitants? And then also for dating waters, it's a very useful tool in understanding the residence time in waters. And then also, if we would expect a water to consistently be 1,000 years old and suddenly it changes to 500 years old, we can assume that there's been a change in the hydraulic head, which I had mentioned before.